Now, in this video, we are going to take up problems on projections of solids. The problem reads as a square pyramid, 35 mm sides of base and 65 mm axis length rests on HP on one of its edges of the base, which is inclined to VP at 30 degrees. Draw the projections of the pyramid when the axis is inclined to HP at 45 degrees. To do this, first we should know how to analyze this problem and to solve by manually. So he says a square pyramid of 35 mm sides of base and 65 mm axis length rests on HP on one of its edges of the base. So since it is resting on one of the edges of the base which is resting on HP has to be perpendicular to VP. So it is similar to a lamina, a square lamina of 35 mm side rests on HP on one of its sides, which is inclined to VP at 30 degrees. The surface of the lamina is inclined at 45 degrees to HP. The same type of problem has been extended here to have the length, axis length. So here we have, since it is resting on HP, so we need to start the problem from horizontal plane, that is from the top view. The edge which is resting on HP, you make that edge perpendicular to VP. Let us see how it will going to take here. So here we can see an edge which is resting on HP is perpendicular to VP. So which are all the two edges which are perpendicular to VP? The edge which is AD and BC are the two edges which are parallel to HP and perpendicular to VP. So once you do that, so here the entire base is resting on HP, that is AB, BC, CD and DA are the edges which are the base edges, because all these edges are resting on XY line. Since it is parallel to HP, so AB equals BC is equal to CD, which is equal to DA, which are is in true length because those edges are parallel to HP. So this is the side. What is the size of the true length? The size of the true length is 35 mm. So this is how we will be able to analyze the base. But when you come to the height is always seen in the front view. If you look from the front view, we can see the height of the pyramid. So the pyramid will always start from the center and it extending on either side of the base corners. So here the height is considered from the XY line. You measure 65 mm to mark that point and join these 2 points. Since it is a pyramid, the front view will going to become a triangle and the top view will going to become a square. And here the diagonals are drawn with a dark line. That is basically because these are the slant edges. Which are all the slant edges? We can see O to A is one of the slant edge, O to B is one of the slant edge, O to C one of the slant edge, and O to D is one of the slant edge. As we have joined between O to A, O to B, O to C and O to D in the top view, obviously in the front view also, O dash to A dash is joined and O dash to B dash is joined. Since O dash C dash becomes invisible and O dash D dash becomes invisible, therefore always the priority should be given to the visible edges. Therefore, we have drawn with a dark line with O dash A dash and O dash D dash. O dash B dash. And the remaining O dash C dash and O dash D dash are invisible, but it is coinciding with both O dash A dash and O dash B dash. Therefore, it is not be shown. So let us see how we can be able to draw by using manual sketchbook. First, we will going to draw the XY line and we will going to mark VP and HP. So in the top view, we measure 35 mm and draw a square of 35 mm and you mark those points as A to B, A, B, C, D and then join the diagonals, and these two diagonals will going to intersect at this point. You mark that point as O and O1 in bracket, because when you look from the top view, O is near to the observer, it is visible, O1 dash is away from the observer, so it becomes invisible, therefore O1 becomes invisible. So from XY line, you measure 65 mm because as the height of the pyramid can be seen in the front view, since VP is the front view, the image what we get in VP is the front view. So from XY line you measure 65 mm and mark a point, and you mark that point as O dash and join. As we are joined between O to A, O to B, O to C and O to D here. Similarly, you join between O dash to A dash with a dark line and O dash to B dash with a dark line and O dash so here as we look from the front view, AB is near to the observer, so A dash B dash is visible. CD is away from the observer, therefore C dash and D dash is in bracket. Since as we look from the top view, O dash is visible and O1 dash becomes invisible. So as we look from the so O1 in bracket. As we look from the front view, since AB is the edge which is hiding that O1, therefore O1 dash will going to become invisible. As we have joined between A dash to B dash, visible to visible is visible, O dash to B dash, visible to visible is visible, O dash to A dash, visible to visible is visible. Therefore, you draw a triangle with a dark line and you represent O dash and O1 dash with a big dash and small dash and big dash. So this is how you will be able to write the front view and also the top view of a square pyramid with the base edges are resting on HP. As the base edges are resting on HP, the base edge which is resting on HP, you make sure that that base edge is perpendicular to VP. So once you have a perpendicular to VP, in VP you will go to get a point. So that is our main intention of getting a point in the front view, so that on that point we can rotate in the second position. Now, then he says the axis is inclined to HP at 45 degrees. So here all of the base edges are resting on HP. What he says that one of the base edges is resting on HP. Which is the edge which is resting on HP? The edge which is perpendicular to VP. Which is the edge which is perpendicular to VP? BC is the edge which is perpendicular to VP and AD is the edge which is perpendicular to VP. Either you can restrict on A dash D dash or you can restrict on B dash C dash. If you restrict on B dash C dash, then I need to rotate in the clockwise direction. If you are resting on A dash D dash, then I need to rotate in the counterclockwise direction. So what I need to do is, I will take any convenient distance from this point and I will go to mark it on the XY line. Since I am rotating with respect to the base edge of B dash C dash, so I will go to mark B dash C dash is on XY line. And then I am rotating the triangle in a clockwise direction. So how to do that? Since it is 45 degree, so since he says the axis is inclined to HP at 45 degrees, you can see that once you rotate this, the axis will going to become inclined and this point will be above the HP. We don't know where exactly this point will going to be, but as we rotate the base by 45 degrees, so what happens? This will going to become a right angled triangle. So if this angle is 45 and this angle is 90, then what is the base line with respect to the XY line, which will also be equal to 45 degrees. Then by using the protractor with respect to the XY line, you measure an angle of 45 degrees in the clockwise direction and then draw a inclined line. Then you measure the distance from B dash to A dash by using the compass. With B dash as center, cut an arc on that 45 degree line and you mark this point as A dash and then you mark this point as D dash in bracket. Then by using the compass, you measure the distance from B dash to O dash and from B dash as center, draw an arc in the front view. Similarly, you measure the distance from A dash to O dash, which is the same as O dash to B dash. Therefore, from here, by taking the radius between O dash to A dash, with this as center, cut an arc on the previously drawn arc. So now you mark that point as O dash. Then join O dash to B dash and O dash to C dash with a thin line first. Then you measure the distance from B dash to O1 dash by using the compass. With B dash as center, cut an arc on this line and you mark that point as O1 dash in bracket. Then join O dash to O1 dash with the big line and small big dash and small dash and big dash. So now the axis will going to be automatically becomes inclined at 45 degrees to HP. Then you dot between B dash to A dash to O dash, and O dash to B dash with a dot line. Once you do that, now I need to write the top view for this. How to write the top view for this? Draw a vertical projector from A dash and D dash to the top view. Draw a horizontal projector from both A and D. These two lines will going to intersect at these 2 points, and you mark that point as A and D. All are thin lines. Then you draw a vertical projector from O1 dash to the top view and draw a horizontal projector from O1. These two lines will going to intersect at this point. Then similarly, then you draw a vertical projector from B dash and C dash to the top view and draw a horizontal projector from B and C to the second position top view. And these two lines will going to intersect at these 2 points. You mark this point as B and you mark this point as C. Then draw a vertical projector from O dash to the top view. Draw a horizontal projector from O1 to the top view, and these two lines will going to intersect at this point. You mark that point as O. Then join A to B, B to C, C to D, and D to A with thin lines. Similarly, as we have joined between O dash to A dash, O dash to B dash, O dash to C dash, and O dash to D dash. Similarly, here also you join between OA and OB and OC and OD with a thin line. Now we will going to apply, once you get this, now we will going to apply the condition of visibility. So what the condition of visibility says, all the exterior edges of the boundaries of the solids are visible. So which is the exterior edges of the boundaries of the solids? That means AB, BO, CO, CD and DA. All these forms the exterior edges of the boundaries of the solid. So according to the rules, you make them visible. So that means join between A to B with a dark line, then B to O with a dark line, O to C with a dark line, C to D with a dark line, and D to A with a dark line. Once you get this, then you have big dash and small dash between O and O1. Next. Then what he says, the surface nearer to the observer is visible. Who is the observer? Now what I am doing is I am writing the top view by looking from the front view. So that means I am looking from here. This is the top view, and the arrowhead will be like this. So once you start looking from the top view, O dash, A dash and O dash, D dash are nearer to the observer. Therefore, automatically these two edges will going to become visible. So we can see what is the top view of O dash, A dash. The top view of O dash, A dash is OA. So you dot between O to A and also O to D with a dark line. So both are visible when you look from the top view here. Then as you look from the top view, the edge which is on XY line in the front view is always invisible in the top view. So which is the edge which is on the XY line in the front view? The edge which is on the XY line in the front view is B dash dash. When you look from the top view, that edge will becomes invisible. So you mark between B to C with a dotted line with a thick line. B to C with a thick line. So this is how we will be able to write the condition of visibility in the second position top view. So here, as we know, is O1 is visible or invisible. Since some portion of the base ABCD becomes invisible naturally, since O1 dash is on that edge, which is on that surface, A dash, B dash, C dash, D dash. Therefore, when you look from the top view, this triangular face O dash, A dash, D dash, when you look from the top view, O to A to D, D to O, which is the triangular face which is visible. So which is that? That is this line what I am talking about. So since this point is below this, so as we look from the top view, this surface OAD is hiding this O1 and also this edge. Therefore, O1 becomes invisible. Now, the next thing is the edge which is resting on HP is inclined to VP at 30 degrees. So how to go about of doing that? So to do that, first we need to check whether that edge is in true length or not. So since B dash C dash is parallel to HP, so I am getting a true length in HP. What is the length of the true length of BC? The length of the true length of BC is 35 mm. Here also BC is 35 mm. Here also BC is 35 mm. Therefore, they are in true length. Since in the given problem, the inclination given is also true inclination from the projections of lines, this line will also be in true. This inclination is also true inclination from the projections of lines on the true inclination line. We will going to get the true length. Since BC is the edge which has to be the edge which is inclined to VP according to the given problem. So since that B dash C dash is parallel to HP, therefore you are getting the true length in HP. So from the projections of lines on true inclination, you have to get the true length. Therefore, what I am doing here, I am rewriting the same sketch by rotating at an angle of 30 degrees to XY line such that the entire base is near to the observer. So consider any point on the top view and then draw a horizontal line. By using the protractor with reference to this point, with reference to the horizontal, you measure an angle of 30 degrees and draw an inclined line. And you mark this point as C. Then by using the compass, you measure the distance from C to B of the second position top view. From C, you cut it on the 30 degree line. So you mark that point as B. Then draw by using the protractor with reference to the C, with reference to this 30 degree line, you measure an angle of 90 degrees and draw a perpendicular to BC. Similarly, you do the same exercise with reference to the point B. With reference to this BC, you draw a perpendicular. Then you measure the distance from B to A, which is the same as from C to D. Similarly, you transfer from B to A and then from C to D. As we know, since we are rewriting the same sketch, then you dot between A to B, A to B and B to C with a dotted line and C to D and D to A with a dot lines. Once you do that, then you measure the distance from B to this point from the second position top view by using the compass. From B, you cut an arc on this dotted line. Then through this point, since this line I want to represent, so this line is perpendicular to this invisible edge. Therefore, similarly with reference to BC line, with reference to this center, you measure an angle of 90 degrees in the counterclockwise direction and then mark a point. From that point, through this line, you draw a perpendicular to BC. Then you measure the distance from this point to O. From this point, transfer it onto this line. So you mark that point as O. From O, by using the compass, you measure the distance from O to O1 of the second position top view. From O, you cut an arc on this perpendicular line and you mark that point as O1 in bracket. So once you do that, then you join between O to A with a dark line, O to B with a dark line, O to C with a dark line and O to D with a dark line. Once you do that, so we will be rewriting the same sketch such that we rotate the line BC by an angle of 30 degree with reference to the XY line. Then you draw a horizontal projector from here to furtherly. Then from B, since BC is B dash C dash is resting on XY line, from B you draw a vertical projector to the XY line, you mark that point as B dash. Similarly from C also, you draw a vertical projector to the XY line and you mark that point as C dash. And then draw a horizontal projector from O1 dash of the second position front view and draw a vertical projector from O1. These two lines will going to intersect at this point. You mark that point as O1 dash. Similarly, you draw a horizontal projector from both A dash and D dash and draw a vertical projector from both A and D. These two lines will going to intersect at these 2 points. You mark that point as A dash and you mark that point as D dash. And then draw a horizontal projector from O dash to the third position front view and draw a vertical projector from O. These two lines will going to intersect at these 2 points and you mark that point as O1 dash. Then join. As we have joined between A to B, B to C, C to D and D to A, then similarly O to A, O to B, O to C and O to D. Similarly you need to do the same thing. So join between A dash to B, join between A dash to B dash, B dash to C dash, C dash to D dash and D dash to A dash, and then join between O dash to A dash, O dash to B dash, O dash to C dash and O dash to D dash with a thin line. Then join between O dash to O1 dash with the dash, big dash, small dash, big dash, small dash. Now, then join between O to O dash to A dash, O to O dash to B dash, O dash to C dash and O dash to D dash with a thin line. Now we will going to apply the condition of visibility. What he says, all the exterior edges of the boundaries of the solids are visible. Which are all the edges which forms the boundary edges of the solid, that is O dash to D dash, then D dash to C dash, then C dash to B dash, then B dash to O dash, then O dash to D dash. So all these edges will going to form the exterior edges of the boundaries of the solids, therefore it automatically becomes visible. Then dark between O dash to D dash, D dash to C dash, C dash to B dash, B dash to O dash with a dark line. Now, the surface which is nearer to the observer is visible. So, as we are looking from here, this is the front view for the third position top view. So, from here you can see that the base is nearer to the observer. Which is the base we are talking about? A dash, B dash, C dash, D dash. So, here that is A to B, B to C, C to D and D to A. All these lines or all these surfaces, this entire bottom surface of the solid becomes visible. So as we have already joined between C dash to B dash and C dash to D dash, therefore you join between B dash to A dash with a dark line and A dash to D dash with a dark line. As we know, the entire base becomes visible, therefore O1 dash will also becomes visible because the entire base is nearer to the observer. Since I am looking from here, since O1 dash is O1 is on the base of the rectangle, which is A to B, B to C, C to D and D to A. So similarly, you have A dash to B dash, B dash to C dash, C dash to D dash and D dash to A dash. Then what he says, from a point, if two edges are visible, automatically the third edge is also becomes visible, which is the edge which we are talking about. From a point, if A dash, D dash and A dash, B dash are becomes visible, therefore A dash, O dash will also becomes visible, therefore you dark them. Similarly, two visible edges can never cross each other. So which is the other edge which is not been completely shown? It's only this edges is left out. As we know, the base of A dash, B dash, B dash, C dash, C dash, D dash and D dash, A dash is visible. Since this edge which is O dash, C dash is crossing this visible edge A dash, D dash, these two visible edges can never cross each other. So apply that boundary condition. As we see, A dash, D dash is visible, therefore since O dash, C dash is crossing that edge A dash, D dash, so it will automatically becomes invisible. Applying this rule, two visible edges can never cross each other. Since A dash, B dash, B dash, C dash, C dash, D dash and D dash, A dash is the entire surface which is visible. So therefore O1 dash is on that surface, therefore O1 dash will also becomes visible in the final position. So this is how you will be able to write the solution and also analyze the problem and solve this problem manually. And how do I know that my problem is right? Even in the final position, you can see it is resting on one of the base edges on HP. Since the edge which is resting on HP is automatically it becomes 30 degrees to 30 degrees to VP. So which is that edge which we are talking about? The edge which is on XY line. in the top view, that edge will going to become BC, and since this BC will be inclined at 30 degrees to VP, and then it is resting on one of the edges on HP, which is P dash C dash, and the surface, the axis is inclined to HP, and since it is a square of 35 mm and a height of 65 mm pyramid. So since we have considered all the data which was given in the problem, and hence my problem is right. Thank you.